Flowcharts look innocent until they start looping. Before we start, I want you to look at this flowchart closely. Predict what do you think will be the final output. Welcome back to my channel, guys. On this video, we're going to be treating question number 7, which is a flowchart problem. And this question is from 2025 October November paper 2-1 of Cambridge IGCSE Computer Science. So here we are. I've placed the questions side by side where we have the flowchart, and on my right hand side we have the truth table. So we're going to be solving this problem using the data given to us here as 20, and then there's another table, 110 as the data, which we're going to use to fill up the trace table. So the first value for count is 0. And then input, we're given 20, right? So remember, we're taking this arrow. This shows the flow of execution. Value equals count multiplied by number. So 0 times 20 will give you 0. So after that, the question is 0 less than or equal to 100? The answer is yes. So we're taking this direction. So count is increased by 1. So we come here, we increase count by 1. Okay, so count is increased by 1. And then when we get here, value becomes 1, which is count, times 20. Okay, so this is 20. So you can choose to just replicate the same value of count if you want, or you can leave count here as empty. Since the value did not change, I don't think it will matter. You'll still get your full marks. Okay, all right, so here we are now. And then is 20 less than or equal to 100? The answer is yes. And then count is also increased again by 1. So count becomes 2, sorry. Okay, so we're going to leave this number and then we'll come here, because value will now be 2 times 20, which is 40. Again, is 40 less than or equal to 100? No, yes. So we'll increase count again by 1, which is 3. Again, this will become 60. So I hope you're following me. Okay. And then on getting here, count is also increased by 1, which is 4. And then we're going back here again. 4 times 20, that will be 80. Question again, is 80 less than or equal to 100? Yes. So we come down here again to increase count by 1, which will give us 5. Again, when we get in here, 5 times 20, that will be 100. Then we're here again, it's 100 less than or equal to 100. The answer is yes, because of the equal to sign there. And then we'll increase count again by 1, sorry. That becomes 6. Okay. So again, 6 times 20, that will be 120. So it's 120. So let's put here, please, 120. Okay. So is 120 less than or equal to 100? The answer is no. So we're coming down here to reduce count by 1. Count reduced by 1 will give us 5, because the last value of count is 6. Yeah. So we will now output count. So we will come down here to output count. That's 5. So that's basically the trace table for the value 20. Okay, so we also need to fill up this one again for the value 110. Okay, so count is 0. The number given to us is 110. So value here will be equal to count, which is 0 times 110. That will give us 0. Is 0 less than or equal to 100? Yes. So we increase count by 1. Again, we are now here. 1 times 110. That should give us 110. Yeah. So question again, is 110 less than or equal to 100? No. So we will reduce count by 1. Count becomes 0. And then we are going to output count, which is 0. Okay. So with that, basically, we've done the job. Okay. So that's for the trace table. The B part says state the purpose of the algorithm on page 8. So which is this this very flowchart here. So we need to state the purpose. So what do you think the purpose is from the truth table that we have done? If you check closely, you would see that the algorithm is trying to find how many times that the inputted number will go into 100. Okay, so because from the output it outputs 5, so that means that by the time it goes more than 100, it is going to reduce the count by 5, so that it will output the last value that is below 100. So basically, so it is checking how many times that the inputted number will go into 100. I think this should be input. Yeah. Okay, so that's basically that. So the C part says state a suitable data type for variable count. Of course, the data type is integer. Yeah. Okay, so finally, I think the D part is write the algorithm in pseudocode. A copy of the algorithm is provided. Okay, so they did another copy here. So they want us to convert the flowchart into a pseudocode, basically. I'm just going to use this exactly as it is to create the pseudocode that we're going to need. So I'm starting from count. I'm looking for a symbol. Yeah, good. Maybe I should copy it so that I can easily paste it. So this will be 0. Next one, input. Before we do the input, we need to declare these guys. Yeah, so it's very important. We need to declare first. So remember that in Cambridge standard, there are keywords and the keywords have to be in uppercase. Okay. Is there any other number that we need to declare? So I think we should equally declare number. So I think with these two declaration, we can go ahead now with the rest of the pseudocode. So the next part is where the input is taken. So we do input number. After that, we now need to do value. Now, if you watch closely, you will see that this is inside of the loop, okay? And this is a while loop. So we need to do this outside so that we'll have the first value for the value here. And then we will equally do it again inside of the loop again in order to have the change in value, okay? Then we now need our while loop. So remember the keywords, okay? While value is less than 100, do. It's very important. Now, it is important for you to indent this, okay? So then we have to increase count by 1. After increasing count by 1, we also need to change the value of, we need to repeat this so that the value will be changing, okay? Because if we don't, this loop is going to run endlessly. So I'm just going to go the lazy approach and copy this. Okay. So having done that, the next thing we need to do, so this is for if this condition returns true, that is yes. So once we're done with this, we're done with the loop. So how did I know that it is a loop? If you have a decision symbol turning back to a previously executed instruction, that is an indication that you have a while loop in your hands, okay? But if you have it coming down to continue further executions without going back to a previously executed code, that means you have an if then else. So having explained that very part, the next thing is for us to do count, to reduce count by 1. That has to be done outside of the loop. Okay. There's something I missed here. And why? And why? Very, very important. when you start your while, you need to end it. It is required as per IGCSE Cambridge syntax for pseudocodes. Okay. So after that, I need to output count. Then I'll end. Okay, let me use stop. Then I'll stop the program. So that is basically, what we should do here. Double check, double check, double check. So I think everything looks good. Okay, so if you have any question, any confusion anywhere, please let us know. If there's any question you want us to treat, we'll as well take care of that. Please do well to like, share, subscribe, and comment. That way this video gets to as many persons as possible. Thank you guys. I'll see you again in the next video. Bye for now.